Are you stressed out trying to keep up with rapid-fire developments in humanoid robotics? You're right where you should be. To keep you in the know, here's the latest in humanoid robots, including a preview of what Figure calls the most advanced humanoid robot ever, NVIDIA's tools for accelerating deployment, the push for physical AI, and a budget-friendly option for do-it-yourselfers. Plus a throwback and more updates you probably missed if you blinked. Remember to subscribe to stay up to date as humanoid robotic technology advances rapidly. Leave a comment to suggest humanoid robots to cover in future roundups. This is the most advanced humanoid robot on the planet. That's according to the CEO of Figure, the OpenAI-backed startup whose humanoid robot is now working at a BMW factory. Brett Adcock announced on X that Figure 02, which follows the Figure 01, will be unveiled on August 6th. Figure released a teaser that VentureBeat notes is short on specifics, but heavy on vibes. The Figure 01 humanoid robot recently started working at the BMW plant in Spartanburg, South Carolina. Figure describes itself as a first-of-its-kind AI robotics company bringing a general-purpose humanoid robot to life. Earlier this year, Figure announced it had secured $675 million in funding from OpenAI and others. The partnership accelerated development of Figure 01's conversational abilities. Weeks after the February announcement, Figure released footage of the robot conversing in real time.
Let's talk about the next wave.
NVIDIA has released new tools aimed at accelerating the deployment of humanoid robots worldwide. The tech giant just announced a suite of tools for robot simulation, learning, and training. A new humanoid robot developer program provides early access to the tools, with companies like Boston Dynamics and ByteDance already participating. NVIDIA says its NIM microservices can reduce robot deployment times from weeks to minutes. The Mimic Gen NIM microservice creates synthetic motion data, while the RoboCasa NIM microservice makes simulation-ready environments. Osmo, NVIDIA's cloud-based service, simplifies robot training and simulation. The company says it cuts development times from months to under a week. Teleoperation, which captures human actions to train robots, can be done faster and cheaper with NVIDIA's AI and Omniverse digital twin tools. The software is compatible with the Apple Vision Pro, which captures human demonstrations that are simulated and expanded into large datasets for training robots. NVIDIA has been vocal about humanoid robots, investing heavily in their development and capabilities.
Humanoid robotics will be as common as cars are today.
Program members get early access to foundational models in NVIDIA's project group. The project, announced earlier in 2024, uses NVIDIA's tech to teach robots how to move and interpret human language. A robotic startup could use a foundational model with their hardware as a starting point. Since the model already knows a lot, the startup can focus on teaching the robot to perform tasks that can't yet be automated.
My name is MenteeBot. How can I help you?
Hey Menti, please take the shopping cart and come with me.
This is MenteeBot, an AI shopping companion in robotic form. Mentee Robotics says a large international retailer suggested deploying robots to push shopping carts for the elderly. The Israeli company says it was also approached by a nursing home chain considering robotics to remedy labor shortages. In response, the team quickly developed a robot that could grab a shopping cart and follow someone in a wheelchair. The robot stops when its shopping companion does and pushes the cart smoothly. The robot is expected to be available to select customers in 2025. Robot success increases by over 67% using digital twins of real-world locations for training. That's according to researchers from the US and Germany who developed a new method for training robots with computer simulations called Real-to-Sim-to-Real or Rialto. First, the physical location is scanned to create a detailed digital copy. With that, a digital twin is built that reflects the physical space in real time. The robot's software operates in the virtual environment, letting it see and interact with objects as if they were real. Robots practice tasks in the digital twin, safely learning and improving their skills virtually. After training in the simulation, the research team says the robots perform the tasks in the real world with much greater success. The study used Franca Amica Panda robotic arms. Tasks performed included stacking dishes and placing books on a shelf. The researchers are affiliated with the Massachusetts Institute of Technology, the University of Washington, and the Technical University of Darmstadt. The study was partly funded by the Sony Research Award Program, the U.S. federal government, and Hyundai.
Hi everyone, my name is Lincoln. In the past 3 months, I built this humanoid robot, RX1, and now I open sourced it.
This humanoid robot is open source and can be built for under $1,000. That's according to Linkeng Zhang, founder of Red Rabbit Robotics in British Columbia, Canada. Zhang says the RX1 has full human-scale robotic arms, built in stereo vision, and understands the world in 3 dimensions. It can be trained to complete tasks using simulation software. Skild AI has secured $300 million to build a foundational AI model to power robots for real-world applications. The round of Series A funding brings the San Francisco-based startup's valuation to $1.5 billion. The company says the funding will go toward advancing AI to make robots more adaptable and useful across industries. Led by Lightspeed venture partners, investors include Cochu, SoftBank, Jeff Bezos, Sequoia, Felicis Ventures, and Amazon. Skild AI says its foundational model is trained on a significantly larger and more diverse set of data compared to competitors. The company says it's working on hiring experts in AI, robotics, engineering, operations, and security to help bring advanced AI into physical reality. Elephant Robotics says its new humanoid robots help researchers bring artificial intelligence into the physical world. The Mercury X1 is a wheeled humanoid robot equipped with dual NVIDIA Jetson controllers, LiDAR and ultrasonic sensing, and an 8-hour battery. The Mercury X1 is designed for mobile tasks and exploration. They also have a semi-humanoid robot, the Mercury B1, which is intended for advanced research. The robot features a 9-inch touchscreen, an NVIDIA Xavier chip, and 3D camera. The robots are geared toward researchers and educators focused on embodied AI. That's when artificial intelligence is embedded into a machine, empowering it to move and interact with its physical surroundings autonomously. The X1 is the first full humanoid robot for the Shenzhen, China-based Elephant Robotics. The company's other robots include a series of cobots and robotic pets. Researchers from UC San Diego and MIT have developed a new system for controlling robots with VR goggles from far distances. The system, called OpenTeleVision, provides an immersive experience. The operator could be as far as 3,000 miles away, as demonstrated by an operator in Boston controlling a robot in San Diego. It mirrors the operator's hand and head movements on the robot, delivering immersive active visual feedback. The robot sends 3D video back to the operator for better visibility into the robot's surroundings. Using the teleoperation method, robots can perform tasks like sorting cans, folding towels, and moving items. The team tested the system with the Chinese-made humanoid robots, Unitree's H1 and Fourier's GR1. They used Apple Vision Pro and MetaQuest goggles for the experiments. The researchers reported high success rates. The H1 and GR1 had a 92 and 87% success rate for picking up cans, respectively. They had more trouble placing the cans in the correct position, with the H1 a success rate at 88% and the GR1 at 60%. However, they both had a 100% success rate folding towels. In its report, the researchers said operators found it easier to control robots using this system compared to traditional methods. The system's code and setup are open source and available online for anyone to use.
NASA's Robonaut has taken its first steps.
During recent tests at the Johnson Space Center in Houston, the experimental robot moved hand over hand outside a mock spacecraft, confirming that it could make repairs or install parts.
NASA calls Robonaut essential to its future mission in deep space. NASA's Johnson Space Center developed Robonaut with DARPA in the 1990s to handle a variety of tasks during missions that were otherwise performed by human astronauts. The robot was commissioned to reduce risks to astronauts, limit mission costs, and expand the scope of space exploration activities. Robonaut was designed with hands capable of using the same tools as real astronauts. The human-like dexterity enabled Robonaut to perform complex, delicate tasks that were too challenging for other robotic systems. Its assigned tasks included maintenance and assembly, extending the scope of what could be automated during space operations. Controlled by teleoperation, Robonaut was ideal for environments unsafe for humans. It had some autonomous capabilities. It made decisions and performed tasks independently thanks to its advanced sensors and processing power. Since it was designed specifically for space travel, Robonaut could withstand extreme temperatures and zero gravity. In 2007, General Motors partnered with NASA to develop the next version of Robonaut.
General Motors and NASA have a long history of working together going back to the original lunar rover. And it would seem like a natural fit for the General Motors Corporation and NASA to work together on the development of the next generation of robots, Robonaut.
The original Robonaut was used as a ground prototype to demonstrate the feasibility of humanoid robotics in space operations. The second Robonaut became the first humanoid robot to fly in space when it was launched to the International Space Station in 2011.
We appreciate the fact that the crew members seem to also kind of take the little brother approach with Robonaut, and that, you know, they treat it like a crew member as well.
On the ISS, it participated in experiments to understand how robots could assist crew members with tasks. The second revision incorporated significant enhancements, making it more capable and versatile. R2 had advanced hands that could use the same tools as astronauts, so it could complete tasks that require fine motor skill. With a higher level of dexterity, the robot's hands and fingers could exert greater force. Its vision and tactile sensors improved its ability to perceive its surroundings. With its advanced sensory systems, the robot could navigate around the space station. Initially, the R2 lacked lower limbs because it was designed to operate from the waist up from a fixed base or mobility platform. Later developments equipped the robot with leg-like mobility so it could move around easier. Its improved computing capabilities meant it could process more information faster and more efficiently. The space industry continues to use insights from Robonaut's development to inform robotic projects for space explorations, including future missions to Mars and beyond, where robots and humans will work together closely to conduct research and establish colonies. Backed by the Hong Kong government, a Beijing-based robotics startup is taking aim at global tech giants in the humanoid robot market. Galbot, founded in May 2023, plans to use Hong Kong as a strategic hub to enter international markets with high labor costs, according to the South China Morning Post. The startup's first humanoid robot, Galbot G1, was showcased at the 2024 World Artificial Intelligence Conference in Shanghai. Galbot plans to introduce the robots to Hong Kong's retail sector within the next 2 years. Wider deployment is targeted for within 5 years. The company has partnered with the Hong Kong Investment Corporation to establish the HK Galbot Embodied AI Lab. Researchers will use the Artificial Intelligence Lab to explore humanoid robotic applications for retail and tourism. The lab will also offer training programs for teenagers on AI for removing humans from dangerous and tedious tasks. Elon Musk has updated the anticipated timeline for Tesla's Optimus humanoid robot rollout. The AI robot is projected to be available for sale a year later than Musk previously indicated earlier this year. On his X platform, Musk said Tesla will have genuinely useful humanoid robots in low production for internal use at Tesla factories in 2025. He said, hopefully, production for other companies will follow in 2026. Musk has set high expectations for Optimus. The humanoid robot is engineered to handle dangerous, repetitive, or boring tasks, and to coexist safely alongside humans in daily life. Elon Musk claims Tesla's Optimus humanoid robot could boost its value to $25 trillion.
I think everyone in the world is going to want one. Tesla would basically make about $1 trillion of profit a year from that. So, yeah.
That's what he said during the 2024 Tesla shareholder meeting. He didn't specify when Tesla could meet that market cap, and the prediction was met with skepticism. The first robot bartender in a big sports stadium is now working at the Texas Rangers Globe Life Field. Richtech Robotics' humanoid robot, Adam, served about 500 drinks in its first week. The Las Vegas-based company says Adam is the first commercially deployable humanoid robot in the US. Fans can order drinks like lemon drops and whiskey sours. The company says Adam makes work easier for stadium employees, especially on busy game days. The robot is located near Section 111 of the stadium. Richtech Robotics develops robots for customer service applications in places like hotels and hospitals. According to reports, Richtech stock on NASDAQ rose after the deployment of Adam in Ghost Kitchens International in Dawsonville, Georgia. It's the first of 240 planned locations. Scientists have developed a new way to make robotic hands with synthetic skin feel more like the real thing. They created tiny, fake blood vessels that circulate water to control temperature. The method makes robotic hands with synthetic skin feel cooler or warmer, simulating the human skin. The Korean researchers detailed their findings in the paper, Thermoregulatory Integration in Hand Prostheses and Humanoid Robots Through Blood Vessel Simulation, published in NPG Asia Materials. They note that service robots are gaining popularity thanks to advancements in artificial intelligence. They say making robots more comfortable to touch can make them easier to interact with. The technology can also make prosthetics more comfortable. The study was funded by the South Korean government through several National Research Foundation of Korea grants. The GR1 humanoid robot has begun training at a China Construction Bank branch in Shanghai. According to China Daily, the general-purpose humanoid robot helps with business consulting, providing information to customers, and guiding people on how to use the bank's smart teller machines. The GR1, by Fourier Intelligence, has advanced AI capabilities and human-like movements. The project aims to improve customer service and efficiency at the bank. New footage of the GR1 general-purpose humanoid robot appears to show a brain-computer interface for robotic control. The Shanghai-based Fourier Intelligence released new footage of the 5'5" humanoid robot. The video notes improvements to the robot over the last 6 months, including more flexible hands, voice interaction training, integration with digital twin technology, and extended reality applications. Weighing 121 pounds, the GR1 can carry objects up to 110 pounds and features 40 degrees of freedom. The robot can navigate complex environments with advanced motion control and self-adaptive balance capabilities. Its camera-based Pure Vision system uses 6 RGB cameras for a 360-degree view. The robot is intended for industrial, healthcare, and domestic tasks. Tokyo Robotics has released footage of its Torobo humanoid robot accurately hammering nails. Torobo has arms with 7 joints that move like human limbs. It's designed for work in industrial environments alongside humans. Standing 5'4", Torobo can feel how much force it uses and adjusts itself to avoid damage. It stops automatically if it bumps into something. It runs on batteries that can work for up to 3 hours. This humanoid robot, designed to mimic the human musculoskeletal system, is able to autonomously operate a vehicle. The robot named Musashi can sit in a car seat, press pedals, and turn the steering wheel accurately just like a real human. The humanoid robot was put to the test as part of the Department of Mechano-Informatics at the Graduate School of Information Science and Technology in Japan's study seeking to improve robotics for future transportation applications. While Musashi could perform driving tasks well, the researchers said there are still improvements needed for diverse driving conditions. Sanctuary AI has secured another round of funding from Canadian investors to bring artificial general intelligence into the physical world. The Vancouver-based company announced new investments from BDC Capital's Thrive Venture Fund and in BC Investment Corp, bringing the startup's total funding to more than $140 million. Sanctuary says Generation 7 of its Phoenix robots have improved human-like movements, visual perception, and tactile sensing, allowing them to perform complex tasks for longer periods. The speed of automating new tasks has accelerated 50-fold. Remember to subscribe to stay hip on the latest in humanoid robotics. Leave suggestions for humanoid robots to include in future roundups in the comments.